Experiment 4 deals with calculating the rate law for this particular reaction. So the goal of this experiment is to figure out your exponents x and y, so the order of this reaction, the order of decay of this reactant, that exponent, it could be 0, first or second order decay. You'll also have to figure out this exponent y, the order of I minus, its decay. Is it 0, first or second order? Now this is real data, so you may get some decimals in there. That's okay, because this is really a quantitative experiment. So you're going to have to figure out x and y, these exponents, also known as the order of the reaction. And then you'll also have to figure out rate constant k. In essence, you're going to get a rate law. So to determine the rate law, you're going to actually make a data table of different types of experiments varying the concentration of one or the other. So before we go further, how will we assess the rate? We will assess the rate by looking at the color. So the color should change almost spontaneously or almost instantaneously to some sort of blue purplish. And the reasoning why that occurs is through this coupling reaction. So this coupling reaction is actually shown here. This is something you don't have to worry about. It's something that's added to your reaction, but you're not calculating the rate law for this reaction. So what happens is that the I2 that is generated in the reaction reacts with this S2O3 minus 2, that's in the coupling reaction. And once all of this I2 is gone, then you will get, once all of this S2O3 minus 2 is gone, the I2 will react with the starch. And the starch is what gives you the color of the reaction. So once again, we're not worried about this reaction. This is only to help us assess the rate. What we are worried about, not the coupling reaction. Our goal here is to get the rate law for this, our main reaction, and to get exponents x, exponents y. Here they have it q and r, it really doesn't matter. And the rate constant k, make sure you have the right units on the rate constant k. We'll do a total of 5 experiments. Here I'm showing you 3, or the lab manual is showing you 3. So here's our main reaction one more time. Here's our main reaction. This is what we want to find the rate law of. So I boxed the 2 main reactants. Okay, the starch just helps you get the color, and these others here are just part of the coupling reaction that you don't have to worry about. So let's compare these experiments. Okay, boxed in is reactant 1, is at 2 milliliters of a 0.2 molar concentration. And then the other reactant, the S2O8 minus 2, is also 2 milliliters at 0.2 molar concentration. Now comparing 1 and 2. Okay, so at 1, we're keeping one of the reactants the same, the I minus reactant, but we're doubling the amount, the volume of the S2O8 minus 2 reactant. Now let's compare experiment 1 and 3. So in experiment 1, we keep the same volume. Okay, the concentrations are all the same, so we're going to keep the same volume, but in experiment 3, we're keeping the same, but we're doubling the other. So in essence, what we're doing in between 1, 2, and 3 is that we keep one reactant constant and double the other reactant. Experiment 4 you'll be doing in the presence of 35 degrees C. So what does temperature do to how fast you're going to get your color? And then experiment 5, you're going to add a catalyst in the form of copper sulfate. So experiment 4 and 5, you're going to follow experiment 1 volumes. And so we're going to add all this up. Okay, one more thing here. We're going to add it in a very specific order. 1, 2, 3, 4, 5. Okay, then you get ready with your lab partner. Once you add 6, okay, the K2S2O8, once you add that, immediately you want to hit the timer and hit it and start timing to see when you will get that appearance of the color. All right, so we're going to begin experiment 1 now, following the volumes on page 4 of your lab handout. So just a word here, all of these are the same concentrations throughout. The only thing you're varying is the volumes. So to get this as accurate as possible, we're going to use these glass pipettes. It may take a little bit of fudging to get to about the 2 milliliter line, which is about here. So watch your line, and let's go ahead and do this. Remember, a very specific order. All right, so it's going to be experiment 1 is going to be 2 mils of this. All right, now NaCl. All right, according to experiment 1, the volume is 2 mils. We got 2 mils of NaCl done. Next up is this S2O3 minus 2. Okay, the sodium is the counter ion. Sodium and potassium, they're just counter ions. They're not going to do anything. So this is 2 mils. Okay, I'm following experiment 1. Here's our starch. Okay, starch won't go into solution, but that's okay. It's not a big deal. This is just something that's going to react with the iodine that's generated. And this is 1 mil, all right? So watch your volumes. This is 1 milliliter of the starch. We got one more to go before we have to get our timer ready, and that is this potassium sulfate, and that is 2 milliliters. So make sure you're putting in the right volumes, okay? All right, so we added everything. We're going to do this in duplicates now, so make sure you and your lab partner have everything set up. We're going to start with 2 mils of this, and then immediately after we put the 2 mils in, I'm going to hit my stopwatch, the timer. It's best maybe if you have your partner do it. 2 mils of this potassium persulfate. All right, once it goes in, we have our timer set up. And so this is where you want to get your partner. Just watch this. We're looking at something that's around 2 to 4 minutes. You know, everybody's lab group will be a little bit different, you know, because not everyone's going to pipette exactly 2 mils and all sorts of other things that can go on. But we're kind of looking for something in 2 to 4 minutes for experiment 1. Again, it may vary from different labs. So we just keep on shaking this or stirring this, and the minute this turns, I think bluish, purplish, we're gonna hit stop on our stopwatch, timer. Right, be patient, it may take a while, it's okay. Again, we're looking for something in 2 to 4 minutes, even if it's 5 minutes, that's also fine. Color form at the bottom, so I'm gonna wait till this whole thing turns blue, and then I'm gonna stop my timer. All right, here we go. Something's happening here. For me, I'm gonna just let it all go blue. Okay, just make that. Yep. Okay. There you go. And about 2 minutes and 45 seconds. All right, let's put that down in our lab sheet. We actually have to convert that to seconds. All right, so we have the temperature of the room. We have a thermometer laying on our lab bench, and I'm getting about 24.5, so let's just go with 24.5 degrees C. And then just leaving a thermometer out in your lab space. So we already got experiment 1. We're starting is going to be 0, okay? And it ended, the blue color came at about 2:45, 2 minutes and 45 seconds. Okay. We're going to have to convert that to seconds. All right, so we can do that in our head, or we can do that a little bit later. But for right now, it took 2 minutes and 45 seconds. Don't forget to convert the whole thing to seconds here. We got to do one more and then take the average. So let's go ahead and do trial number 2 of experiment 1. All right, so we finished experiment 1, the first trial. This is experiment 1. The second trial. Okay, this is for all the students that are doing this virtually. 2 mils. We're still on experiment 1, the second trial. And let's see here. So the first one was 2 minutes and 45 seconds, and that actually, converting that to seconds, is about 165 seconds. So this should be around that time. If it isn't, that's okay. That's why we take the average. Something's starting to show up here. Me, I like to have it completely blue, but so any moment now, I'm going to keep on shaking it, and the whole thing's going to turn blue like in the first trial. So again, you just want to be patient. This is literally like ink. All right, I think, yep, let's stop it here. So, what did we get here? Looks like we got 2 minutes and 49 seconds. That's actually pretty good. Reproducibility. So let's go back here. All right, trial number 2. We started at 0 and we got 2 minutes and 49 seconds. I'm just going to go ahead and convert these to seconds. So 2 minutes is 120 seconds. 120 seconds plus 145 is 165 seconds. And 2 minutes is 120 seconds plus 49 gives me 169 seconds. So we can do the average later. Let's do experiment 2, where we actually double the concentration of the K2S2O8, the potassium per sulfate. All right, now we are on experiment 2. Okay, so experiment 2, our first trial. Once again, the difference between experiment 1 and experiment 2 is we're doubling the amount of K2S2O8, this potassium per sulfate. So we got to do this twice. Actually, we have a 4 ml one. And so get a 4 ml glass pipette, and let's go ahead and do this. Stuff's happening, and any moment now the whole thing's going to turn blue. Oh, there we go. Yep, stop. Minute 20, let's go with a minute 25. So let's come back here. Initially 0, 0. 1 minute 25 seconds, so 1 minute is 60 seconds plus 25 is going to be 85 seconds. All right, trial number 2, experiment 2. All right, here we go, experiment 2, trial number 2, 4 mils of the K2S2O8. All right, let's stop it. All right, this came out pretty good, consistent with the other one. 1 minute and 19 seconds. So let's go back to our data sheet here, is what the stopwatch says. Let's go ahead and convert that to seconds. That's about 79 seconds. We can take the average later. And what's next on tap is experiment 3. The difference between experiment 1 and 3 here, we're doubling the NaI. Okay, we're doubling the sodium iodide. All right, so here are experiment 3 conditions according to the table. Okay, we're going to add 2 mils of this. And let's go. All right, so here's 2 mils. So this potassium persulfate, experiment 1 we added 2 mils, experiment 2 we added 4 mils, the concentration is 0.2 molar, and now in experiment 3, this tube, we're adding 2 mils, but we doubled the sodium iodide. Okay, so it looks like some stuff is happening. Okay, like I said before, we want this totally blue, and this is the first of our duplicate runs for experimental 3 conditions. Let's stop there. And 1 minute and 18 seconds. So let's go back here to our data table. In my head, I'll convert that. That's about 78 seconds. We can take the averages later. All right, now we're going to do our second trial for experiment 3. All right, so our duplicate, our second run for experiment 3 in those conditions. Alright, stuff is happening here. So, keep on going with that shaking. There we go. Nice. 1 minute and 17 seconds. Let's go back here. So experiment 4, we're going to do this in a water bath, exact same conditions as experiment 1, but we're going to do it in a water bath that's at 35 degrees C. All right, so experiment number 4 here is under some special conditions. It's at 35 degrees C. So here, for those of us that are doing the lab in person, we've set up a water bath that's set at 35 degrees C. And so we can just put that in here. So before we start anything, a lot of prep work before we do this experiment, the 4th experiment. This trial run is done at 35, so everything is done at 35. So what we have here is all the materials from experiment 1, so the experiment 1 volumes here, except the K2S2O8, the potassium persulfate. The potassium persulfate here is sitting at 35 degrees all by itself. Okay, so this is at 35. Everything except the potassium persulfate is at 35. Again, I want to reiterate, special emphasis, these are all experiment 1 volumes. These are all experiment 1 volumes done at 35 degrees C. And so now I'm going to take 2 mils of this. This is our K2S2O8 potassium persulfate. Add it to here. We'll do a quick shake and then record the temperature change, this time at 35 degrees. All right, so 2 mils. Take a little while here. I'm actually going to remove this as well. Alright, so here is our 2 mils. Remember, this is at 35 degrees C, higher temperature. That little cork in there. Give it a good shake. We already have the timer set up, and let's see what happens here. This should be at a higher temperature. Do a little bit more of a shaky thing. So it's starting to come up. Let's go here. So I see a blue coming up. I'm going to just shake it up a little bit more. Come on. Yeah, there we go. So about a minute 18, minute 19 or so. Let's go with, because I was a little bit late in the delay, let's just make it a minute 17. Okay. All right, so experiment 4 at 35 degrees. We started at 0, and minute 18, minute 17. We'll just go with a minute 17. In experiment 5, we're going to do exactly the same thing as experiment 1. The only difference is that we are going to add a drop of copper sulfate. This is supposedly a catalyst, and a catalyst, as we know, makes a reaction go faster. So again, I want to reiterate it. In test tube 5, experiment 5, exactly the same volumes as experiment 1, but we're going to add a little bit of this, actually 1 drop of this copper sulfate, and then we'll add the We'll add the K2S2O8 to initiate the reaction. Potassium persulfate. So just 1 drop of this. So experiment 1 volume is 2 mils. We're going to add 2 mils of this. Let me get this out of the way and get our timers and everything started. So 24, let's say 25 seconds. So yeah, that's pretty fast. This is, copper sulfate is a very, very good catalyst for this reaction. All right, so experiment 5 with our copper sulfate catalyst, we got the emergence of this dark blue purplish color at around 25 seconds or so. We'll just say 0.25 seconds. So we're only doing this once, so the elapsed time is 25 seconds. I went ahead and computed the averages for the experiment 1 duplicate, the experiment 2 duplicate, the experiment 3 duplicate. Once again, experiment 4 was done at 35 degrees C, and experiment 5 was done with 1 drop of the catalyst, copper sulfate.